Welcome. In this video, we're going to give introduction to the integration by parts. Then some questions may come up like, why are we using this? And we're not using Udu, for example, which you have seen in the other videos. Now, imagine that you have something like this. X sine of x dx. Now, if you have an integral like this, if you try to solve it, you may be tempted to try to solve this thing using our substitution Udu. But now, we are going to notice something. This function, which is a power, and this function, which is trigonometric function, have nothing in common. This function has a different nature, and this function has a completely different nature, which means for our Udu, for us to find the u here, let us say we take u as x. There is no du here. There is no du, and if you take u as sine of x, there is no du here because this function has no relationship with this function here. So therefore, our method Udu cannot work. Now, in such situations, there is a method that can work, and that method is called the integration by parts. So whenever you see that you have here a function in which the two components, or we consider the two functions that are involved, they have different nature, in those cases we use the integration by parts. Now, there is a form that we're going to apply always that is so when you're solving integration by parts, which is u dv, this is v, is equal to u uv minus integral of v du, uv minus integral of v du. Now, there's something else that we also talked in the beginning of our study of integration, which was the relationship between integral and derivative. We have derivative, and we have another thing called integral. There is a relationship between these two here. And what is this relationship? Is that these two are opposite operations. Those are opposite operations, which means that derivative is the opposite of integral, the integral is the opposite of derivative. Now, this is very important to know because this method of integration by part depends on this relationship. Now, in Udu substitution, we just take our u and then we see its derivative over there, and then we just have our function given. But we know that in this case it's not going to happen when we have a function like this. So there's a need for us to choose or to select u and also to select a v. Say for example you have a function, let us take this function here, integration of, let us say, x cubed natural log of x dx. Now, what do we consider u? What do we consider as v? We cannot guess, we cannot simply guess. Now, maybe due to experience and doing exercise, practicing a lot, you will end up getting the grip of it. But to choose u and v, you don't choose it by luck, you don't choose it just because you love it, we just choose it because there is a principle in which you have to follow, there is a rule. Now, what is our u? Our u is what you're going to differentiate. Fine. And our v is the integrated. Got it? So this is how we make our variables. You have u and v, which are functions in this case. One for differentiation, one is for integration. Now, to select our u, we have to follow a principle. We have to first of all check what is the log, if there's a log in the function, and then we have to check if we have inverse trigonometric function, and then we're going to check if we have a power of x, and then we're going to check if we have trigonometric functions, and then also finally going to check if we have exponential functions. This is going to be for log, this is going to be inverse trigonometric function, this is going to be power, and this is going to be trigonometric function, and this is going to be exponential. Now, exponential is something in which you have a constant that is raised to the power x, while power of x, it means x raised to some constant. Okay, there's a difference between this. Fine. So what we do is we have to check in order for us to decide what is our u, which is the variable or the function that we're going to differentiate. We have to follow these rules. The first thing we find is going to be our u, and the next thing after we find u, the remaining part is the dv. Fine. So check this. Here we have x raised to 3. This is power of x. This is here. And here we have natural log of x. This is natural log. So it is log. It is the first thing. So this means what? This means that in this case our u is natural log of x, and our dv is equal to x cubed dx. This is how we select what is going to be our u and what's going to be our dv. Fine. Let us take another example. We have here, for example, another function. Let's say we have x tan of x dx. Fine. You don't have to be guessing this. You just have to know that this is a power of x and this is a trigonometric function. And then come here in this, you go downwards like this. So you have log here, you don't. You have inverse trigonometric, you don't have. Do you have power? Yes, you have power. So this. Therefore, our u is equal to x and our dv is equal to tan x dx. This is how you find u and how you find the dv. Fine? That's really good. Now let us take an example here, so that we know how to solve these kind of functions. Say for example we have we can actually go for this function itself. Let us try to solve this function here, which already started. Fine. In this case we know that our u is natural log of x. Why? Because in this rule here the first thing that is going to be found is log, which is here. Good. And this is going to be our dv. So let us make it better. Fine. So in this place you only have u's, in this place you're going to have v's. If this is our u, then what's going to be the derivative of our u? And this is log. The derivative of this is going to be what? Derivative of this is going to be 1 divided by x dx. So you can just say dx by x. Fine? Good. So it means what? It means that you got this thing here, and then you came to this side, you made a derivative, and you got it here, right? But the next thing we have in this function here, it's not v, it is dv. Fine? So this is going to be dv on the other side. dv is going to be x raised to 3 dx. Got it? Yeah. This function itself, it's already an integral. As you can see here, we always have this dx in the end. So this is one of the cases. This is already an integral function. So what do we have to do here? We have to integrate this function. This we had, and then we find the derivative, and this we had like this, in which one to find what? The integral. So we come down for integral. That is the importance of this point we mentioned here. Derivative is opposite of integral. So this is x cubed dx. You want to find integral. Integral of dv, integral of this is going to be what? V. It's going to be v. Fine? Good. Now then we have this. In order for us to find the integral of this, we have to remember the power rule of integration. What is the power rule of integration? Is that you keep x. In this power you have, you increase 1, you're going to have x raised to 4, and then you divide this thing by the same power you get in the end. So you're going to have x4 divided by 4. Got it? Fine. So it means that now we have our u, we have our du, we have our v and our dv. So we are ready to apply this form. Now solving this, we can solve it from here. This we can solve it from here. So we have our u dv is equal to u v minus integral of v du. Fine. Now what is our u? Our u is natural log of x. It's here. Done. What is our v? Our v was the integral of this dv here. So it's going to be x raised to 4 divided by 4 minus the integral of our v, which is this one, integral of this dv, which is also our x raised to 4 divided by 4, and then it's multiplied by du. What is our du? Our du is dx by x. It's going to be what? Dx divided by x. And we continue. Very good. We can take this input to this side just to make things a little bit better. So we're going to have this natural log of x minus. Now this is 1 divided by 4. It's a constant. We can take it outside, and then we're going to get this integral. See, we have x raised to 4 divided by x, so this can become x raised to 3 dx. Fine, and this is going to give us x raised to 4 divided by 4 natural log of x minus 1 by 4 into integral of x raised to 3. This again is the power rule, so this is going to give us what? This is going to give us x raised to 4 divided by 4. Fine, this is a case of an indefinite integral, which means we need to have a constant c, but I'll just put the constant c in the end. Fine, then you're going to have here x raised to 4 divided by 4 natural log of x minus. You have this here, you have this here. So this we can just say it is, we can keep it like that. We can say it's x raised to 4 into 4, which is actually 16. And then we can take this common. This x raised to 4 divided by 4, x raised to 4 divided by 4. We take as common, we have x raised to 4 divided by 4, which are taken common, natural log of x minus 1 divided by 4. And then now we can put here plus c, and we got our result. Fine. So our u we find the derivative, and our dv would be the remaining part. We just find its integral, we apply to this form, and then we solve.